Alright, we're going to be talking specifically about domain and range right now. So, to help us focus, I've already found the inverse of my function. My original function is half x plus 2 quantity squared. My inverse of that then would be positive negative 2 times the square root of x minus 4. Alright, can I have the blue-black marker? And here's my assistant. There we go. Now remember, when we talk about domain, hey Xander, what does domain start with? D. Very good. So when I talk about the domain, these are the values of x that will work in my function. When I look at this, the question I'm asking basically boils down to, are there any values of x that would return a non-real answer? In short form, if you're dealing with a radical of any kind, then you know that x must be greater than or equal to 0. Whatever's under the radical must be greater than or equal to 0. And if you're dealing with a rational equation, then you simply know that y cannot be equal to 0. Because you're not allowed to have a denominator of 0. Right? Okay. So let's talk about my domain up here. So, if I look at this, are there any values I can plug in that I'm not going to get a result out for? I can't think of any. Can you? No. Yeah, you got to scoot forward a little bit. They can't see you. There you go. So, I want to write all real numbers. What letter does real start with?
R.
R. Very good. Now, in math, if I want to talk about the set of all real numbers, I put a bar in my R, like that. Is that how you normally make your R's? No.
Not really.
No. And that's why I have that extra line to show that it's not just an R, it's the set of all real numbers. It's a lot of numbers, isn't it? Okay. Let's talk about range. What letter does range start with?
R.
It also starts with an R. Very good. So now the range is, as I put numbers into this expression, what numbers am I going to get out of it? This might take a little bit more work to think of. You may want to graph it. You may want to plot points, create a table of values, come up with various different ways to see what this is going to look like. When I think about the graph of this, it's going to be a parabola that's shifted 2 units to the left. So it's going to look like this. So my range are all the numbers bigger than 0. So my range is the set of all y such that y is greater than or equal to 0. And I can test that by putting some numbers in for x and see what I get out for y. No matter what I do, though, I'm still going to always find, even when I put in, say, a negative 4 here, I'm going to get 0 as my lowest value. This graph will never go down below 0. Sound good? Alright. Alright, now let's take a look at what happens when we look at the inverse of this. I want to find out again the domain and the range for this function over here. So, I need a marker. What color should we use? Blue. Alright, now, domain. What letter does domain start with again?
D.
D. So my domain is going to be the values that this does not work for. Now, remember we noted over here, right above Xander's head, that if there's a radical involved, whatever is under that radical must be greater than or equal to 0. In this case, my radical is simply x, so that means my domain is limited to values of x greater than or equal to 0. Now, another way I might write this is the domain is the set of all x's such that x is greater than or equal to 0, and then I can close my set off. This would be the set notation way of talking about this. Alright, new color.
Let's do the red one.
Do the red one? Alright, now, when I talk about range, which starts with an R, when I want to talk about range, I'm talking about what values I get out when this is all over. So are there values that I'm not going to get as a result of this? Now I notice here, I've got this plus minus 2. So that means that every time I put a value in for x, I'm going to get 2 values out for y. It also means that any real number I can think of that will work in there, any number inside my domain, is going to kick out a value that's both positive and negative. If I were to draw a graph of this, my graph is going to look like a stretched out sideways parabola shifted down 4 units. So it's going to look something like that. And as I can see, this is going to keep going up and up and up, isn't it? If I keep going this way, that's going to keep going up, right? How high is it going to get? Really, really high, infinitely high. In fact, I actually can use any number I want. Now, Xander, do you remember what we write when we want to say all reals?
X.
Not quite. What letter does real start with?
R.
Starts with that R. Is it a normal kind of R or is it a special kind of R?
Special.
Special, because it has that bar on it. So in this case, my range is all real numbers. I need one new color. What should I use? Purple?
Yeah.
All right. Now, the last comment about this domain and range. Let's compare the domain and the range for the original function with the domain and the range for the inverse function. Notice, the domain of the real function is the range of my inverse. And if I look at the range of my original function, it has become the domain. You got this down so much you're yawning?
Yeah, but I'm not tired.
Bet you're not tired. You sound like one of my students already. It becomes the domain and range flip. Alright. The last thing is in our conversation that has to do with this domain and range is what I want to do is graph these and show that we're looking at a reflection across the line y equals x. Now that line we know is a diagonal line at 45 degrees that cuts right through there. Now earlier in the problem I mentioned that this parabola was going to have a x-intercept at -2 and I misspoke. It's going to have an intercept at -4. Now that doesn't change the range any. It still bottoms out on that -4. So 1, 2, 3, 4 right there. And now I also know that when I look at a y-intercept, if I put 0 in for x, I'm going to get +4. 1, 2, 3, 4 right there. And so I'm looking at a parabola that's going to do something along these lines. Now when I go to graph this, it's a sideways parabola because of the square root of x. It's shifted down 4 units. And then again it's got that half which determines how fast it grows and it shrinks. What makes it interesting, can I have the purple one? Thank you, sir. 1, 2, 3, come down 4 units right there. I'm going to find that I'm looking at pretty much the same graph going this direction as well. So that when I look across that line, I have that reflection. Because remember, a function, f of x, and its inverse should reflect across this line y equals x. All right, want to say goodbye?